Welcome back again. So today we are going to start with the story of resistance. All right. So here yesterday, if you were already there in the yesterday's session, you know that we already started with the most scoring chapter. And yes, we have done some PYQs also, if you remember. And even if you people, any of the new learners out there have just started, have just joined. So today we will do Ohm's law and many more important things regarding the Ohm's law. So without taking too much time, let's talk about the story of resistance. Okay. So now we are talking about the Ohm's law. What does Ohm's law say? Ohm's law says that if there is a metallic conductor for us, if there is a conductor, it is going to offer some sort of opposition to the flow of current. If you maintain a potential difference across it, suppose we have connected one end to the higher potential, another end to the lower potential, okay? Then the current flowing through the metallic conductor is directly proportional to the potential difference applied, VHL, where VHL is equal to VH minus VL. Yes, the Ohm's law says that this current flowing and this potential difference applied when you are analyzing with respect to each other, then you are doing this at constant pressure without applying any mechanical stress, this, that. But here we are majorly right now focusing on the mathematical part. How do you express that? Okay. So the current is directly proportional to the potential difference applied. If you convert the proportionality into the equation, and constant of proportionality can be kept on either side. We are just having a habit that we will put the constant of proportionality on the right hand side. But it's not necessary here. The constant is anyways a constant. It can be put on any of the sides. So VHL can be written as I into R. VHL can be written as I into R, where R is termed as the resistance. R is termed as the resistance, a resistance that is opposition to the flow of current. Opposition to the flow of current. Now, what you have to remember is that if I say here, mathematically, we can also have this relation that resistance is given as VHL by I. Resistance is given as VHL by I. So if we say, generally it seems that if I increases, it seems that if I will increase, then mathematically R will decrease. And if VHL will increase, then R will increase. Okay, if numerator increases, fraction value increases. If denominator increases, fraction value decreases. But all of this is wrong. All of this is wrong. The reason is that resistance is a constant of proportionality. Resistance is constant of proportionality in the Ohm's law. Okay. So now what we have learned is that resistance does not depend on the current and voltage. Mathematically, it seems that resistance depends on VHL and resistance depends on current. But the fact is that doesn't depend on any of them. So tell me in the comment section quickly that then resistance depends on what? If resistance doesn't depend on current, if resistance doesn't depend on potential difference VHL, then you tell me that resistance depends on what? So resistance, in fact, I will say that resistance depends on first thing, you will say the length. Second thing, you will say the area of cross section. Third thing, you will say nature of material, whether it is iron, steel, aluminium, wood and all. Nature of material, conducting, very good conductor, poor conductor, like those things. And fourth thing is temperature. In fact, I would say that if you change the temperature, you are indirectly changing the absolute nature of material. So hence, these are the things on which the resistance depends. And how it depends, sir? we will say the formula is given by R equals to rho L by A. R equals to rho L by A, where rho is also called as resistivity. Rho is called as resistivity or specific resistance. Specific resistance. Hope that's okay. Resistivity or specific resistance. I hope that's clear to you. All right. So this is a brief overview regarding the Ohm's law. That Ohm's law is applicable at constant pressure, at constant temperature majorly, without any mechanical deformations and all. So you will say that it is observed in Ohm's law that if you plot the current versus VHL, then you will realize that current is directly proportional to the potential difference applied. And here if you try to find out this slope, so I will say here slope M, which is tan phi. If you remember, in every interaction I am talking the same, that it is basically it is perpendicular by base. Tan theta is perpendicular by base. So that perpendicular, that's di by dVHL, or here you will say that's I by VHL. So mathematically VHL by I is R. So I by VHL will be 1 by R or G. So the reciprocal of resistance is also called as conductance. See, resistance is opposition to the flow of current, and its reciprocal conductance will be support to the flow of current. If resistance is more, you oppose the flowing current more. If conductance is more, you support the flowing current more. I hope all the things are clear to you. No, that's not conductivity, that's conductance. Reciprocal of resistivity will be conductivity, but reciprocal of resistance will be conductance. Is that all right? So I hope the brief overview of the Ohm's law is clear to you. Now quickly take the screenshot so that we can start our journey with the NEET PYQs. Take the screenshot. All right. Right, chaliye, let's move ahead. So there is a problem. Question: the resistance of a wire is R ohm. If it is melted and stretched to n times its original length, its new resistance will be. So I will give you a tip first. I will say, then we will answer this question. For melting and stretching, compressing problems, for melting, stretching problems, mechanical operations problems, no cutting and deposition, no extra material, no cutting and deposition. So you are just taking the volume conserved. If you are stretching it, you are conserving the volume. If you are compressing it, you are conserving the volume. If you are melting and for molding into a new shape or size, you are again conserving the volume. So for this tip I am giving you for volume conservation problems. It is not applicable for cutting and removal problems. It is not applicable for deposition problems. And what is the tip? We will say resistance, which can be written as rho L by A. So naturally rho L by A, L can be written as volume by area. So that will be rho V by A square. So clearly you can say the resistance is not inversely proportional to A, but resistance is inversely proportional to A square. So generally resistance is inversely proportional to A. But here for these type of problems, resistance is inversely proportional to A square. Similarly, we can also say R, which can be written as rho L by A. Now this time I will express area. Area can be written as volume by length. Length can be written as volume by area. Area can be written as volume by length. So that will be rho by V into L square. So clearly General problems के लिए resistance is directly proportional to length, but here resistance is not directly proportional to length. But for these type of problems, resistance is directly proportional to L square. Resistance is directly proportional to L square. So let us conclude. I think we have understood what I was saying. So here what we can say, I will say the resistance of wire is R ohm. It is now made n times its original length. Given that length final will be n times. Length final will be n times length initial. And we know that for these type of problems, R final is directly proportional to L final ka square. This implies R final will become n square into R initial, and hence the correct option is n square into R initial. That should be, its new resistance will be, I think one of the option has been misprinted. That should be n square R, n square R. If it is melted and stretched to n times its original length, I think that is n square R. I'll just correct this option. Yeah, so the correct option is now n square R. Hope everyone is good with it. Option B. Okay. Okay. So if you stretch it n times, if you stretch the length becomes n times, from the previous formula, it seems that if L is made n times, the resistance is also made n times. But from this formula, we can see if length is made n times, the resistance will be made n square times. Right? Hope that is understood. You can quickly take the screenshot. Take the screenshot. All right. Right now you are taking the screenshot, but don't forget to join the Telegram group. The link is already given in the description, so that all the important updates, the study material and all the quiz tests are given in that group. All right. Chaliye. Let's talk about another question. Question is, a 6-volt battery is connected to the terminals of a 3-meter long wire. So that's a 3-meter long wire. 3 meter long. This length is 3 meter. Okay. And the potential difference applied from here to here is 6 volts. 6 volts. Now what they are saying is the difference of potential between 2 points on the wire separated by a distance of 50 centimeters. So suppose there are 2 wires, 2 points on the wire, point M and point N. The distance of separation between them is 50 centimeter. What they are asking you is, they are asking you what is the potential difference between Mn. What is the potential difference between Mn? That's the problem. I hope the question has been understood. Okay. Now what you can say? We will say here, we know Ohm's law. Ohm's law, VHL is equal to I into R. That will be I into rho L by A. Here, the resistivity is going to be constant. The current, naturally the same current will enter the wire, the same current will flow throughout the wire, and same current will be leaving the wire. So we will say I is constant, I is going to be same, and rho and area is also going to be constant. Uniform wire it is. Uniform wire. So if all these things are constant, can I say, if all these things are constant, can I say this implies VHL is directly proportional to length. VHL is directly proportional to length. All right. So this concept I am going to use. What you can write here is, here 6 volts. 6 volts is directly proportional to 3 meters. 3 meters. And VHL is directly proportional to 50 centimeters, or you can write it as half meter. Let us divide. The moment you will divide this, what do you get? You will get 6 by VHL is equal to 3 by half. This simply means that VHL is going to be, were you having this 6 volts? Yes. 6 volts and 3 meter. So 2 volts and 1 meter. 2 volts and 1 meter, and from here 1 volt and half half meter, 50 centimeters. I hope you got the logic. All right. So the correct option is 1 volt. Absolutely correct. I really like when you people answer the NEET PYQs even faster than me. And our students have become faster. Very nice. You can take the screenshot, then we will move ahead. Okay. Understood? Hope you have taken this screenshot. Let me take you to another one. Now, another question, a very nice question. My favorite problem. I like this. Favorite problem from this model. Okay. Now, we will see how to do this problem. So, see what is given to you. Given it, see, we know they are talking about the mass ratio. Mass ratio is given to you. Given is M1 ratio M2 ratio M3. That is equal to 1 ratio 3 ratio 5. And length ratio L1 ratio L2 ratio L3. It is given as 5 ratio 3 ratio 1. Both the materials are same. All the materials are same. Copper. Material is same. Same material means, that is, you will say resistivity and density. Resistivity and density both are going to be same. Both are going to be same. Okay. We will see how to do it. Now, we can proceed like this, that we will say that electrical resistance ratio R will be equal to rho L by A. But we don't have the idea regarding the area or the resistivity. Let's say the resistivity is rho only. The length is given as L because length we know. And area can be written as volume by length. So what you got is rho by V into L square. Now we also know that density is equal to mass upon volume, or volume can be written as mass by density. So that can be rho L square, and this volume can be written as mass by density. So what you got is rho dl square by m. Rho dl square by m. So what is to be understood is, here is that clearly the resistance is going to be directly proportional to L square by m. As density and resistivity both are going to be same. Density is mass per unit volume. Volume can be written as mass by density, but density and resistivity are same because of the same material. So what we can say is R1 ratio R2 ratio R3, that must be equal to, you can say L1 square by M1 ratio L2 square by M2 ratio L3 square by M3. So L1, L2, L3, L1, L2, L3 are in the ratio 5, 3, 1. So that is 5 square, ratio 3 square, ratio 1 square. And the masses were in the ratio 1, 3, 5. So that is 1, 3 and 5. So what you got is 25 ratio 3 and 3 will cancel and 1, 3 will be remaining. And it will be 1 by 5, or in proportion that should be written as 125 ratio 15 ratio 1. 125 ratio 15 ratio 1. So the correct option is D option. 125 ratio 15 ratio 1. Very nice. I can see few people have again answered it very soon. Very nice here. Very nice. So see, very like in the starting journey of your STAR program only, you are doing so many PYQs. I hope you are liking it and you are able to cope up with it. Maza aa raha hai? Chaliye, you can take a screenshot. Quickly take the screenshot. It's an important one here. I personally like this problem, so need to emphasize on that. Okay? Yeah. So we have done some 2-3 questions from the PYQs already. Let's move on to another topic now. Let's try to learn something more. Series combination of resistors. Series combination of resistors. How does it look like? So between 2 points A and B, suppose we have 3 resistors like this, R1, R2, R3. Now what we can say here is conditions. what are the conditions, and what is the relation? What is the relation? Formula: equivalent resistance. Equivalent resistance formula. So condition is, as you can see, whatever current enters from R1, the same current goes from R2, the same current enters from R3, goes through R3. So you will say current I must be same. Current must be same. The potential difference VHL may vary. So that may vary means that may be same. Can be changed, may be same, depending upon the value of R. Depending on the value of R. That is, what you can say is that VHL is equal to I into R, out of which current is considered to be same. This implies VHL is directly proportional to R. That means that in a series combination of few resistors, if two resistors are having identical value, the potential drop across them will also be identical. Greater resistance value will have a greater drop, lesser resistance value will have a lesser drop. Greater resistance, greater potential drop, lesser resistance, lesser potential drop, equal resistors, equal drop, unequal resistors, unequal drop. So who will decide whether the drop will be equal or not? Entirely decided by the value of R. Okay. So you will say that this is VHL versus R, and this VHL versus R, we are going to get a straight line passing from the origin. What about the equivalent resistance, sir? Equivalent resistance formula is R series equivalent can be directly written as R1 plus R2 and so on up to Rn. For two resistors, you can simply say that R series will be equal to R1 plus R2. For n identical resistors, you can say that R series will be equal to R plus R plus R plus R. So that is going to be NR. In terms of conductances, I will say that resistance can be replaced by reciprocal of conductance. So you will have 1 by GS will be equal to 1 by G1 plus 1 by G2 and so on up to 1 by Gn. And for identical one, you can clearly say that G series will be like the way you have R series will be equal to NR. This implies 1 by G series will be equal to N into 1 by G, or you can say identical के लिए I'll directly relate the reciprocal one. For identical एक काम करते हैं, let's do it here only so that you won't get confused, you will get the looping. I am saying that let's do it here only, that GS will be equal to G by N. Conductances. So resistance will have multiplication wala relation, so conductance will have the reciprocal relation of that. Okay, so I hope that's cool and clear for you. This I can change the color and this also. I hope now you can emphasize on all the important things. Okay, is that understood? I hope everyone got the idea of series combination. The current is going to be same. The potential difference may or may not vary depending upon the value of R, depending upon the value of resistance. And this is how the resistance can be related. Okay, right? Understood now? Chaliye. Let me take you to other results. Now this time we will be talking about the parallel combination. I'm increasing the size a bit because I'm looking at the screen and it seems to be a bit smaller for you. Okay, now I think it will be clearly visible even if you are viewing this lecture on a mobile phone. Chali, you can take a screenshot here. Take the screenshot. Right. Very soon again we will start with the PYQs. Let's see first. So parallel combination of resistors. Parallel combination of resistors. Now what is that? First of all, how does it look, sir? How does it look like? So I will say parallel combination looks like this, that between 2 points A and B, there are suppose several arms. One arm is having a resistance R1 here, another arm is having a resistance of R2, and another arm, third arm, is having a resistance of R3, and there can be a number of things like that. So conditions. Condition is, first of all, I will say potential difference VHL across AB, potential difference across all the resistors must be same. Must be same. Series में current must be same. VHL may or may not be same. Parallel में VHL, the potential difference applied must be same. Current may or may not be same. Current may be different. So it may be same, it may be different. Who will decide that, sir? Depending upon the value of R. Depending on R. Now, how does it depend on R? You will say that is VHL equals to IR may, this time the VHL is going to be same. So, I is inversely proportional to R. Means bigger resistor will have a smaller current, smaller resistor will have a bigger current. Bigger resistor will have a smaller current, smaller resistor will have a bigger current. Identical resistors will have identical currents, and unidentical resistors will have unidentical currents in parallel combination. So it may be identical, it may be unidentical. And if you are going to plot a curve, if you are going to plot a graph here, I will say I versus R, you are going to get a rectangular hyperbola. Inversely proportional graph looks like this. That if R is very huge, current is very, very less. If R is very less, current is very, very huge. Like that. Okay. Let's talk about further. What about the equivalent resistance? Equivalent resistance is, I will say the combination will be 1 by RP will be 1 by R1 plus 1 by R2 and so on up to 1 by Rn reciprocal, or in terms of conductances, it will be direct addition. Gp will be equal to G1 plus G2 and so on up to Gn. Similarly, I will say that for n identical resistors, we will be having 1 by Rp will be equal to 1 by R plus 1 by R plus 1 by R and so on n times. So that is n by R. This implies R parallel will be equal to R by n. And remember, the G parallel will be equal to Ng. Okay. So this is going to be, these are going to be the general relations, particularly for identical resistors or identical conductors. But before that, another important relation for us is for 2. It's a very common one, very common. And you have seen that in earlier stages, that for two resistors, the parallel combination resistance is given by R parallel equals to R1 R2 by R1 plus R2. Means generally we say that is product over sum. Product of resistances over sum of resistances. So this was just to give you a recap. Now whatever you have studied till 10th class, the NEET syllabus more or less is also going to be based on that. Definitely we will talk about the in-depth concepts, but the more things we have to, like more focus we have to put on is more number of problem models. So in today's interaction, we have already discussed 3-4 NEET PYQs, which have recently come also. So quickly take the screenshot. I'll take you to some more problems. Take the screenshot. What is conductance? Krishna has just joined. I hope all of you have taken the screenshot of this. Krishna, I said already that conductance is reciprocal of resistance. So all the new learners, you are more or less familiar with the resistance. The reciprocal of resistance will be called as conductance. Similarly, reciprocal of resistivity will be called as conductivity. All right. Chaliye. Let's start with another problem. What they are saying is the effective resistance of a parallel connection that consists of 4 wires of equal length, equal area and same material. So what is given to you? Given the length, area and material means resistivity. Everything is same. This implies identical resistors. You are dealing, this question is based on identical resistors, already a NEET PYQ. And how many of them? 4 of them. 4 of them. That is, n value is equal to 4. Okay. Now, if the effective resistance of parallel combination also R parallel is given to you as 0.25 ohms, then they are asking you what is the effective resistance if they are connected in series. R series is what? That's the question. Length, area and material is given to be same, which means you are dealing with identical resistors, 4 identical resistors. So parallel combination resultant is 0.25 ohm and series combination they are asking. How to solve this? We will say we know for n identical resistors, for identical resistors, R series by R parallel. R series is actually given by NR and R parallel is given by R by N. See, that's what we have learned. R parallel is R by N and R series is NR. R series is NR and R parallel is R by N. Okay, so R and R get cancelled, you will get N square. This implies R series will be equal to N square into R parallel. That means that will be equal to N square. N is 4, that's 4 square into R parallel, that is 0.25, 0.25. Naturally 0.25 is nothing but 1 by 4, 1 by 4 will cancel 1, 4 and hence the final answer is 4 ohms. So the correct option with us is option 4, that is 4 ohms. I hope the logic is very much clear to you. So see, it is more or less the same things which you have already discussed in the 10th class, but NEET questions are actually going to be very easy provided you people do the problems regularly, you learn the concepts in depth, and whenever you will come to us here, all the classes you have to listen properly. Whenever teachers are teaching us, our maximum focus should be on the words, what the teachers are teaching. Okay, so whatever the thoughts are, the way our teachers are thinking about any new problem, we as a candidate should also be trying to think the same way. So if we learn the ability to deal with any new problem, then that's the end, that's the completion, isn't it? Yeah, so I think that's clear to you. You can quickly take the screenshot, then we will move ahead. And guys and girls, focus on the learning. I can see the chat section, but you are not talking about the physics. Okay, yeah, Rajni, what is the difference between conductivity and conductance? The way you say the difference between resistivity and resistance is, resistivity depends on the nature of material. Okay, you also call it specific resistance. But resistance depends on the nature as well as the geometrical configuration. I mean, if you take a conductor, if you take a wire and you deform it, you change its shape and size. So its resistance can change, but its resistivity will not change. So resistivity is entirely a material dependent quantity. Similarly, you can say that conductivity will depend on the medium, that is a reciprocal of resistivity, whereas conductance depends on the geometry, length and area also, just like resistance. I hope I made it very clear. Let me take you to another problem, another NEET PYQ. What is that? The current in the following circuit is, so there is a circuit diagram given to you, you have to identify the current. So if you see that carefully, I'll redraw it for you here. So that's a 2 volt battery, and then that's a 3 ohm resistor, and then that's a 3 ohm here and 3 ohm here, 3 ohm here and 3 ohm here. Can I say that these two are actually in series combination? I mean, I'll draw the diagram. I've drawn the diagram, I'll just magnify it. See, these two, whatever current flows through it, the same current is flowing through it. So these two can be taken as series combination. So if they are in series combination, you can directly add them up, R1 plus R2, R1 plus R2, so their equivalent is 6 ohms. R1 plus R2, their equivalent is 6 ohms. Now you see the right arm having a 6 ohm and the middle arm having a 3 ohm are in parallel combination. So you will say these two are going to be in parallel combination. So I will say here, R equivalent finally will be equal to R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. 3 into 6 by 3 plus 6. 3 into 6 by 3 plus 6. 6 into 3, 18. By 6 plus 3, 9. Hence the final answer is 2 ohms. So they were asking you the current in the following circuit, Ohm's law. I is equal to VHL by R. So potential difference, how much is given? Only one ideal battery, 2 volt is given, and resistance is given to you as 2 ohms. So that's 2 volts by 2 ohms, and hence the answer is coming out as 1 ampere. So the correct option is option A, 1 amperes. Hope the logic is clear to you. 3 and 3 are in series. 6 into 3 by 6 plus 3, that is in parallel. 2 ohms, 2 volt, 2 ohms, answer is 1 amperes. Okay. Quickly take the screenshot. All right. So hope you have understood the today's interaction. That is based on Ohm's law. We started with the basic discussion of Ohm's law. We talked about the series combination. We talked about the parallel combination. And yes, we have also talked about a lot of PYQs. So this was just the introductory section of current electricity, which we started yesterday. The story of resistance we have started today. And the remaining part we will definitely do in depth when very soon we will be able to see you all in front of us. Till then, take care, enjoy the learning, and yeah, don't forget to like, subscribe and share this channel to all of your friends who can also take the advantage of this STAR program and can learn a lot. And yes, the Telegram group is already available in the description of the video. You should click the link and join the channel, because Telegram channel, because there we will be sharing all the important content, assignment, quiz and updates with you.
Did you all understand the yesterday's topic? How to do the basic stoichiometric questions? Before we start with the class, everyone, I hope you guys know that you have to like the session as well. These were yesterday's questions we have done. This was the question we were talking about. Chocolate question. Okay. Did you guys solve it and got the answer 9.33 or not? This question is similar to the question that I will just ask you. Okay. You know that each Maggi packet is 12 rupees. Okay. Today each Maggi packet is 12 rupees. And each Lay's packet is 20 rupees. Lay's packet 20 rupees. Maggi packet 12 rupees. Question is, how many Lay's packet can you buy in the same amount of rupees in which you can buy 5 Maggi packets? Think. How many Lay's packets can you buy in the same amount of rupees which gets you 5 Maggi packet? It's the same question only, no? It's the same question. First you checked that we are talking about 5 Maggi packet. Each Maggi packet 12 rupees. 5 Maggi packet 60 rupees. Then you came, it went to your mind that yes, now 60 rupees we are talking about. Then you went to the shopkeeper. You gave him 60 rupees. Each Lay's is 20 rupees. He gave you 3 Lay's packets. Now it's the same question. Here rupees is oxygen. Maggi is aluminium. Lay's packet is ethane. Okay. Mind calculation. Same thing is here. Exactly same thing. Okay. Exactly same thing. Now are you able to relate it what I am saying? when I gave you two different scenarios, one Lay's packet scenario, one Maggie packet scenario, what was common between them? Money was common. Money was common between them. Between these two reactions, oxygen is common. So first I will find that how much oxygen is actually used for the combustion of 2 mole ethane. First I will find how much oxygen is responsible for combustion of 2 mole ethane. That much oxygen I have now. From that much oxygen, how much aluminium I can buy, I will check. Yes, that's all simple now. Now let us write the two reaction. First I'll write the ethane reaction. Listen the question carefully. How many Lay's packet can be bought with the same amount of money which can bring us 5 Maggie packets? Same question. First I will see Maggie versus money. Maggie versus money. Maggie is mole. Ethane. Ethane is Maggie. Okay. Oxygen is money. Oxygen is money. And aluminium is Lay's. Just think. If you can think nicely, hi Hasini, hi Srave, you can do later Subba Lakshmi. I know they are your friends. I am your better friend. No, I will tell you new things also. Don't say hi to each other. So first from the ethane, I will check how much oxygen is actually available to us. How much oxygen is actually available to us? Ethane, C2H6 gas, combustion, O2 gas, gives CO2 gas, H2O liquid. Okay, we'll balance it now. Balancing. 2 carbon, 2 carbon. 6 hydrogens. Here 2 are there, I will multiply by 3, 6 hydrogens. Now oxygens. 2 2s are 4, 4 plus 3, 7 oxygens are here. 7 oxygens are present here. This side only 2 are there, so I will multiply with 3.5. I will multiply with 3.5. This is the balanced reaction. 1 mole react with 3.5 mole to give 2 mole and 3 mole. Okay. Now we will find the oxygen. How much oxygen is required for 2 mole ethane? So we can see that here ethanes are known. 1 mole ethane requires 3.5 oxygen. So 2 mole ethane will require 7 mole oxygen. Money we know now. We know the money, 60 rupees. That 60 rupees is 7 mole oxygen here. 60 rupees is 7 mole oxygen here. Now what is the next step? Next step is same money we will take to aluminium now. How many moles of aluminium means how many packet of Lay's can be purchased with 7 mole oxygen? How many packets of Lay's can be purchased with 7 mole oxygen? I will write the reaction of aluminium with oxygen. Second step. I am writing here second step. Aluminium plus oxygen give Al2O3. You all know the formula of aluminium oxide. Balance it. So I'll make it 2 times. I'll make it 2 times. So 4 aluminium, 6 oxygen. I'll make it 3 times, 6 oxygen. Okay. So we can say that 4 packet of Lay's come from 3 mole oxygen. 4 packet Lay's from 3 mole oxygen. 4 packet Lay's, 3 mole oxygen. But I have how much oxygen? 7 mole oxygen. So we'll say 3 mole oxygen. 3 mole oxygen buys us 4 Lay's packet. 3 mole oxygen buys us 4 Lay's packet. So 1 mole oxygen will buy us how much? 4 by 3 Lay's packet. So here the question was regarding 7 mole oxygen. So we can say 7 mole oxygen will get us how much? 7 times 4 by 3. 7 times 4 by 3. 7 times 4 by 3. Tell me, is it clear to everyone or not? Quickly tell me, is it clear to everyone or not? Seven mole oxygen can buy us 4 by 3 into 7 Lay's packet. So 9.33 moles of aluminium can be purchased. We'll talk about limiting reagent today. I gave you one scenario yesterday where I told you that if there are so many bread slices but only 4 cheese slices, then how many sandwiches can be formed? You said, sir, only 4 sandwiches. Why? Because here the breads were too many. Breads were too many. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Like that, so many breads were be available. And cheese slices were only 4. 1 cheese slice, 2 cheese slice, 3 cheese slice, 4 cheese slice. You said that, sir, first sandwich will be made when I will use 2 breads and I will use 1 cheese. Second sandwich, 2 more breads, 1 more cheese. Third sandwich, 2 more breads, 1 more cheese. Fourth sandwich, now cheese is over. So finally only 4 sandwiches we can make. So something which finishes the earliest in a reaction is called as limiting reagent. So here cheese is limiting the amount of sandwiches. Okay. Cheese is limiting the amount of sandwiches. Cheese is saying, I will decide how many sandwiches can be made. Bread, you will not decide. Although breads are 22, but I can't make 11 sandwich because cheese is getting finished. So limiting reagent decides the product formed. It is limiting reagent which will decide how much product you can obtain. Bread cannot decide. Even if I take 5,000 breads here, still 4 sandwich. Even if I take 8 breads, still 4 sandwich. Even if I take 10,000 breads, still 4 sandwich. Yes. So this is the case of limiting reagent. Now how to find the limiting reagent? All of you see carefully. Okay, all of you see carefully. Now I will be talking about how to find the limiting reagent. So write down these things, all of you. Limiting reagent. All of you write it down. It is the reactant which finishes or gets consumed the earliest in a chemical reaction. It is the, all of you can stop chatting in between. Okay. Most of you are studying, so you are behaving like a good student, like a 11th standard student. There are some people in this class who are behaving like they are still in the 4th standard. So we will, if possible, you also tell them by their name that Harshvardhan, you are in 4th class, you are an idiot. Like that you can mention, not a problem. Okay, so those who will be talking about each other, talking about Instagram, small 1 minute gyan I will give you. Okay, 1 minute I will tell you, Manga, Harshvardhan, you will not become any successful person by getting 2-3 follows from your friends. You should not be able to, you should not be telling your friends to follow you. They should follow you because they like you. Okay. So study properly so that one day you become a good doctor and then everybody will follow you. I will also follow you back. I will also follow you back, but don't talk here. The reactant which gets consumed the earliest in the chemical reaction. Now, how do you come to know which will get finished the earliest? How do you come to know? There is a trick for that. Okay, there is a trick for that. So you can just first mention that note point. Amount of product obtained only depends on amount of limiting reagent. Amount of product obtained only depends on amount of limiting reagent, and it is independent of excess reagent, because I just showed you that sandwiches will be 4. It depends on only cheese, not on the bread. Okay. So amount of product obtained only and only depends on what? Amount of limiting reagent. Okay. One thing to keep in mind, everyone, I'm just asking a small question to you. Just think carefully. Okay. Think carefully and then answer. Think carefully and then answer. I take 2 gram hydrogen, 2 gram hydrogen and 8 gram oxygen and I react them. 2 gram hydrogen, 8 gram oxygen and I react them. Then you tell me who would be the limiting reagent. What do you think? First thing, as I say, as I tell you the question, what comes to your mind? 2 gram hydrogen, 8 gram oxygen. Who is the limiting reagent here? 2 gram hydrogen mixed with 8 gram oxygen. Who do you think is the limiting reagent? I am not saying the one which is present in less weight. I am saying limiting reagent is the one which gets consumed the earliest. How do you know hydrogen will get consumed or oxygen will get consumed? It will depend on the reaction. No? It will depend on the reaction. You tell me, what is the reaction? Reaction is H2 gas reacts with O2 gas to give H2O. I can balance it like this. H2 gas plus half O2 gas give 1 H2. That means 2 grams of hydrogen, 2 grams of hydrogen react with 16 grams of oxygen. 2 grams of hydrogen react with 16 gram of oxygen to give 18 gram of water. Okay, to give what? 18 gram of water. Now you think, for 2 gram hydrogen to get consumed, you require 16 gram oxygen. Do you have 16 gram oxygen? Do you have 16 gram oxygen? For 2 gram hydrogen to get consumed, you require 16 gram oxygen. Do we have 16 gram oxygen? No, sir. No, sir. So, oxygen is the limiting reagent, not hydrogen. So, as soon as, think about, 2 gram hydrogen requires 16 gram oxygen. So, when I take 8 gram oxygen, it will require 1 gram hydrogen. So, what will happen? Complete 8 gram oxygen will get consumed, but only 1 gram of water, hydrogen will get consumed. Okay? Yes. So, how to find the limiting reagent is what I am telling. Every time you will not check like this. If you didn't get, not a problem. You directly start with how to find the limiting reagent. So, limiting reagent is not the one which is present in less grams. Limiting reagent is not the one which is present in less grams. Limiting reagent is the one which gets consumed the earliest. What is the trick to find limiting reagent? Write down. Trick to find limiting reagent. Just do given moles by stoichiometric number. Just do given moles by stoichiometry. Wherever this given moles by stoichiometry comes lowest, that is limiting reagent. First write it down, then you will understand. Given moles by stoichiometry. Given moles by stoichiometry. Wherever you get, I will write a GM by S. GM by S. Given moles by stoichiometry. How many moles are given to you? Divided by what is the stoichiometry. Whichever number comes small here, that is the limiting reagent. Now I am giving you the same question again. All of you write down the question. Question was 2 gram hydrogen reacts with 8 gram oxygen. 2 gram hydrogen react with 8 gram oxygen. Find. We have to find following things. Number 1, we have to find which is limiting reagent. Second, we have to find which is excess reagent. Third, we have to find weight of water obtained. These 3 things we have to find. See carefully. Okay, see carefully. Good, Charan. First thing what you do is everything same. Question is, now look at the question. How do you come to know that it's a question of limiting reagent? Because I gave you the weight of both the reactant. I told you, whenever data for both the reactants will be given, then question is from limiting reagent. How to solve? First you balance the reaction. You write the reaction H2 plus O2 H2O. Gas, gas, liquid. Okay. Balance it. However you want to balance, you balance. Let us balance it like this time. 2H2O, 2 hydrogen. Okay. So what is the stoichiometry? Stoichiometry is 2, 1, 2. Stoichiometry is 2, 1, 2. Now, what are the given moles? Given moles. I am writing it as GM. Given moles. How many moles of hydrogen is given? See, 2 gram hydrogen means moles of hydrogen are 2 by 2, 1 mole. This is given 1 mole. 1 mole given. Oxygen is given 8 gram. 8 by 32 is the molar mass, which is 1 by 4 mole. So this is given 1 by 4 mole. Next step, always do given moles by stoichiometry to find limiting reagent. Given moles by stoichiometry just to find who is going to finish first. So do what? Given moles by stoichiometry. Simple. Given moles by stoichiometry. Let us do. Given moles are 1, stoichiometry is 2, 1 by 2. Given moles are 1 by 4, stoichiometry is 1, 1 by 4 by 1. Okay. Now can you see that? All of you tell me. Can you see that 1 by 2 is large, 1 by 4 is small number? 1 by 4 is small number, yes or no? 1 by 4 is small number, yes or no? Don't delete the chat, let it be. 1 by 4 is small number? Yes. So just circle it, saying that you are small number, you are limiting reagent. You decide everything. You decide everything. Everything will depend on you only. Everything will depend on oxygen. Oxygen will say how much water I want to form, I will form. How much hydrogen I want to consume, I will consume. I will decide everything. Okay. So now, forget about all this thing. It was not required afterwards. Just to check limiting reagent, we checked it. After that, forget about it. You don't require any of this data. This data was just to check who is the LR. You can do it in mind also. It doesn't have to be written like that. You can do it in mind. Just take given moles by stoichiometry. Think who is small. This will decide. Now start with the question. First one. Who is the limiting reagent? It is oxygen. Who is the excess reagent? It is hydrogen. How much H2 is obtained? Oxygen will decide. Oxygen will decide. Just talk to oxygen. Think that hydrogen is not there in your question only. Think that hydrogen is not there in the question only because hydrogen is not deciding anything. Yes. So you ask oxygen. Oxygen says when 32 gram of my when I react 32 gram 1 mole oxygen, it gives 2 mole water. Means we can say 32 grams oxygen gives 36 gram H2O. I am saying it from this reaction. From this reaction, 32 gram gives 2 mole, means 2 times 18 gram water. I am comparing these two things. 32 gram gives 36 gram. So 8 gram oxygen will give how much? 1 will give 36 by 32 and 8 gram will be multiplied by 8, which will give 9 gram water. Slowly tell me. Is it clear to all of you or not? Will you be able to do this? First 1 or 2 questions, you might feel that it takes time. Third question, fourth question, fifth question, sixth question will be able to do very nicely, easily. Okay, it's a difficult topic, I know, but yes, crystal clear, very good. Very good. Okay, good. Do you want to solve one question now? Do all of you want to solve a question now? Yes. Okay. Good. All of you try this. Try this. I will give you time. Don't worry. I want you to take proper time for this and solve it. Then I will tell you. Question says, calculate volume of CO2. CO2 is a product released at STP when 12 grams of ethane is reacted with 1 mole of oxygen. That means data of both the reactants is given. Sandwiches are also given, cheeses are also given, but we don't know which is limiting. We don't know which is limiting. How to check which is limiting? Given moles by stoichiometry. First we write the reaction. Without writing the reaction, question can never be solved. C2H6 gas, O2 gas gives CO2 gas, H2O liquid. 2 carbon, 6 hydrogen, multiply by 3. Here will become 7 oxygen. So here I will keep 3.5. If you feel like, sir, this type of balancing looks difficult to us, you balance it in this way. Okay, you balance it in this way. First you balance the hydrogen. You make it 2 times. Now 4 carbons are there. You make it 4 carbons. Hydrogen you make 6 water like this. Now oxygen you count. 4 2s are 8. 8 plus 6, 14. So I will put 7 oxygen here. Any balancing is fine. Okay, any balancing is fine. So 2, 7, 4, 6. These are the stoichiometry. Stoichiometry. 2, 7, 4, 6. Now I am checking for limiting reagent. I will do given moles by stoichiometry. Given moles by stoichiometry. Now, given moles. First you find the moles. 12 gram of ethane. Moles will be 12 gram by 30 gram, which is molar mass. 12 by 30. So here given moles are 12 by 30 or 0.4 I can say. Divided by stoichiometry, which is 2. 0.4 by 2. Okay. Given moles of oxygen are 1 mole. 1 by 7. 1 by 7. So this is 1 by 5. If I see carefully, this is 1 by 5. This is 1 by 7. Okay. This is 1 by 5. This is 1 by 7. Correct? 0.4 moles are given. By stoichiometry is 2. 0.4 by 2. Sorry, this is 1 by 5. Yes, this is 1 by 5. And 1 mole of oxygen is given. Stoichiometry is 7. It is 1 by 7. So this becomes our limiting reagent, which is small number. This becomes our limiting reagent, which is 1 by 7. Okay. Now, we will say oxygen, you will decide. Oxygen, you decide. Whatever product you want to form, you only form. Third option, fourth option, let us see, I don't know. I don't know which option is correct, but you have to solve it completely. Oxygen, you decide. So oxygen says 7 mole oxygen produces 4 mole CO2. 7 mole oxygen produce 4 mole CO2. 4 mole CO2 means 4 times 22.4 liter CO2. Okay, I am writing the volume data. 7 mole produce this much. 1 mole oxygen is given. So 1 mole of oxygen completely will get consumed. It will produce 4 into 22.4 by 7. 4 into 22.4 by 7. 12.8. Is it coming 12.8 or is it coming more than that? Fourth option. Okay. 12.8. That is correct. Okay. So this is the question. I know limiting reagent question require one extra step. So they tend to be little more difficult from the basic questions. Fourth option is correct. Most of you are saying 3 and 1. Okay. Again listen. Again listen. I am telling once more. Those who are saying no, that as soon as question comes, we are not able to think. When you look at a question and they tell you the amount of all the reactants, A is reacting with B. They give you amount of A also. They give you amount of B also. Your brain will tell, I have to find which is finishing first, because that only will decide. Okay. So here they have given 12 gram of ethane, 1 mole of oxygen. Both the things are given. So first thing I am checking, given moles by stoichiometry. 12 gram ethane means 0.4 moles. By stoichiometry of ethane, as you see, it is 2. 0.4 by 2. This is the number which I am getting for ethane. Same way for oxygen, 1 mole is given, stoichiometry 7. 1 upon 7. I compared 1 upon 7 versus 0.4 by 2. 0.4 by 2 is 1 by 5. So ethane is 1 by 5. Oxygen is 1 by 7. Oxygen is in less amount. So oxygen will decide how much product will form. Okay. I hope it is clear. Then according to oxygen, just make the... Yes, we will do question. We will do question. One more shall we try? Do you want to try one more? Yes or no? Are you guys enjoying this limiting reagent topic? Please say yes or no. If you are enjoying, just mention enjoying. Okay. You trust me. When you ask your seniors, no, they will say it is the most difficult topic. But if you compare it with your everyday life, no, it's actually a very easy topic. All of these things can easily be understood when you compare them with the daily life things. Okay, good. All right. Yes, confusing is fine. Confusing is fine. If it is confusing, then I am happy. Because obviously this topic, if it is confusing, means you are trying to understand. If you are trying to understand, you will get it. H2 mixed with Cl2 to give HCl. Reaction is H2 gas react with Cl2 gas. All of you see here, gives 2HCl. This is the reaction. So tell me, what is the stoichiometry? 1, 1, 2. Stoichiometry 1, 1, 2. Now we will read the question and we will see why it is from limiting reagent. 22.4 liters of hydrogen gas react with 11.2 liter of Cl2 gas. This is also given. This is also given. So question is from limiting reagent. Question is from limiting reagent. So how to find the limiting reagent? Do given moles by stoichiometry. Okay. What are the moles of hydrogen? To find the moles, formula is given volume by 22.4 liter. Those who are with me from the very first class, they will be very easily be able to tell this. 22.4 liter means 1 mole. So this is given 1 mole. By stoichiometry also 1. Chlorine is given 11.2 liter. So moles of chlorine are volume by 22.4. 11.2 by 22.4. 1 by 2. Given moles 1 by 2. Stoichiometry 1. 1 by 2 divided by 1. So limiting reagent comes out to be what? Limiting reagent comes out to be chlorine. I will decide. I will decide how much HCl will form. Finish. That's all. So now start with the unitary method. 1 chlorine gives 2 HCl. 1 mole chlorine gives 2 mole HCl. We have half mole chlorine. So half mole chlorine will give 2 times half. 1 gives 2, half will give 2 times half. 1 mole HCl. Option 1. Option 1. Is it clear? Was it simple or difficult? Tell me. Was it simple or difficult? Yes, we will do one more. Sushant, we will do one more. Thank you, Afia. Is it simple? Clear? Yes. Okay. One more. Let's go. Solve this one. Similar question you have done already. First question was like this only. Quickly do. I'm writing the reaction. Let us quickly do. H2 reacting with O2 to give H2O. Balancing, we know we can do 2H2 plus 1 O2 give 2H2O. Stoichiometry is 2, 1, 2. Now we'll check limiting reagent. Given moles by stoichiometry. Because the value of both the things are given. Hydrogen is given 10 gram. So moles of hydrogen, you can write separately like this. Moles of hydrogen is 10 gram by 2 gram, 5 mole. And moles of oxygen are 64 gram by 32 gram, which is 2 mole. So this is given 5 mole, 5 by stoichiometry 2. 2 by stoichiometry 1. Okay. So 2.5, 2. I will decide. I am the limiting reagent. Okay. So oxygen will decide. That's all. Finished now. 1 mole oxygen gave 2 mole water. So I can say full oxygen will get consumed. 64 gram oxygen you have taken. 1 mole give 2 mole means 32 gram oxygen. 1 mole means 32 grams of oxygen produce 2 mole H2O. 1 gram of oxygen will produce 2 by 32 moles of H2O. And complete 64 gram oxygen will produce 2 by 32 into 64, which is 4 mole. Answer is option 4. Clap for yourself, those who are getting correct answer. All right, one difficult question. First do this one, then we'll do a difficult question. Let us do, first thing, write the reaction. 4 ammonia react with 5 O2, give 4 NO, 6 H2O. Always write the physical state as well. Okay. Stoichiometry 4, 5, 4, 6. Okay. When 1 mole of ammonia and 1 mole O2 are mixed, given moles by stoichiometry. Why am I doing? Because ammonia and oxygen both are given. Moles only are given. 1 mole and 1 mole. So 1 mole by stoichiometry 4. 1 mole by stoichiometry 5. Who is the limiting reagent? Again oxygen. By chance, whatever question I have given today, in every question, oxygen is coming out to be the limiting reagent. No problem. This is the limiting reagent. So, oxygen will decide. 5 oxygen produce 4 NO. So, we'll say 5 mole oxygen produce 4 mole NO. How many oxygens are given to us? 1 mole. This 1 mole only will decide. 5 gives 4. 1 mole oxygen gives 4 by 5, which is 0.8. Clap yourself, those who got answer as first option. One question is there for your homework. You will get this file after this class. Okay. In the Telegram channel, I hope all of you have joined the Telegram channel. If you have not joined, please do that. Link is there in the description. Also, please fill the form which is there in the description. It is going to help us as well. Okay. And you as well, if you want to join here. All right. So fill the description form. One chocolate question which is there, you have to do yourself. Thank you very much. Bye bye. See you. I hope it is clear to everyone. These things you already know. You have to subscribe to the channel as well. Bye bye. If you are enjoying the session, please comment as well after the session is over. Okay.
Hi students, hello. This is Vishweshwar Rao, Botany lecture, Sri Chaitanya, Gosala campus. In last class, development of male gametophyte and microsporogen is completed. Next part of the sexual reproduction is megasporogenesis and development of female gametophyte, structure of ovule. pistil, ovule, embryo sac. It is the female reproductive organ. Pistil is the female reproductive organ. In structure of flower, female organs, carpels. Whorl of carpels is known as gynoecium. Whorl of carpels is a gynoecium. In a typical flower consisting of 4 organs. First one, outermost one is the sepal, second one petal, third one stamens, fourth one carpels. Whorl of stamens is the endoecium. Whorl of carpels. Whorl means all the carpels are found in a flower together called as the gynoecium. Gynoecium is situated exactly on thalamus. This is the thalamus of a flower. Gynoecium is placed on this thalamus. Gynoecium is consisting of many carpels. These are female reproductive organs. Gynoecium consisting of carpels. Number of carpels in each gynoecium 1 to many. The number may variable from plant to the plant or species to species. Number of stamens in endoecium also different from flower to flower or species to species. Number of stamens in endoecium variable. Number of carpels in gynoecium also variable. All the carpels are found in gynoecium either fused condition or free condition. If all carpels are free, not fused with another one, then the condition is called as apocarpus. Apocarpus status. If the carpels are fused, one carpel is fused with another carpel on the same gynoecium. Syncarpus. Syncarpus. Apo, free. The meaning of the syn is fused. F-U-S-C-E-D. Fused carpels or united carpels. Fused carpels, syncarpus gynoecium. If the carpels are free in a gynoecium, that kind of gynoecium is called apocarpus condition. Observe here. What is the difference between A gynoecium to the B gynoecium in 2 different flowers? In A, number of carpels are many, but all are united to form single structure. That's why it is syncarpus. Okay, good. Syncarpus. Yes, fine. Syn means fusion. Fusion, English word, syn, technical name or scientific name. Apo, free. Carpel 1, carpel 2, third carpel, fourth, all carpels are free. The number of carpels, whatever it may be. But one carpel doesn't fuse with another one. That is meaning for apocarpus ovary. Generally, in majority of the flowering plants, around 99% of flowering plants, syncarpus ovary is there. Apocarpus ovary is a rare condition. Apocarpus is rare condition. If there are more than one carpel, such condition is generally termed as the multicarpellary. Based on number of carpels, gynoecium also classified into different types. If only one carpel is there in gynoecium, G for gynoecium, the number, this alphabetic number 1 clearly explains number of carpels. G2, 2 carpels. G3, 3 carpels. If only one carpel is there, the name of that gynoecium is the monocarpellary gynoecium. Monocarpellary, single, gynoecium with a single carpel is a monocarpellary. If the 2 carpels are there, bicarpellary. Number of carpels are 3, tricarpellary, 4, tetra, 5, penta, more than 5, multicarpellary. Tetracarpellary gynoecium, pentacarpellary gynoecium, more than 5, infinity, multicarpellary gynoecium. Multicarpellary gynoecium. If the number of carpels are more than 1 at a time, apocarpus condition is possible, or syncarpus condition also possible. If only one carpel is there at the time, it is not possible to differentiate the gynoecium with the apo or gynoecium with the syncarpus. This kind of differentiation is not at all possible in monocarpellary. That kind of differentiation is possible in bi to multicarpellary status. This is the gynoecious structure in hibiscus plant. Structure of gynoecium hibiscus. Hibiscus is the special case. Within a single carpel, ovaries, styles are fused, only stigmas are free. I think already you know, each carpel is differentiable into 3 portions. Basal swollen part of the carpel is the ovary. Middle part is the style. Terminal part is the stigma. Terminal part is the stigma. Especially in the plant hibiscus, gynoecium consisting of 5 carpels means pentacarpellary ovary. It is a peculiar case. In this pentacarpellary ovary, 5 ovaries are fused, 5 styles also fused, but stigmas are not fused, free stigmas. Stigma 1, 2, 3, 4, 5. 5 stigmas are free, but styles fused, ovaries also fused. So hibiscus is not an example for completely syncarpus or completely apocarpus. It is a semi condition. It is one peculiar character found in hibiscus. Here stigma 1, 2, 3, 4, 5. All the stigmas are free, but the styles and carpels are fused. In case of one plant Michaelia, number of carpels are many, that's why it is a multicarpellary. And apocarpus, what is the meaning for apocarpus? All carpels are free. This is the real image of the plant Michaelia. Carpels are free. Free means apocarpus condition. Okay, based on fusion and free condition of the carpels, gynoecium broadly classified into 2 categories, such are syncarpus and apocarpus. Total, how many pods are there in each carpel? How many pods are found in each carpel? Other name of the carpel is the pistil. 3 pods are there. Basal swollen part is the ovary, but the most important part, because ovule producing part of the ovary is carpel is the ovary. Middle elongated part is the style. Terminal part is the stigma. It is the basal swollen ovary, style, stigma. Stigma, style, ovary. Among these 3, how can you consider ovary is most important? Ovules born inside of the ovary. That's why it's the most important one. What is the functioning of the stigma? The stigmatic surface is the site for landing of pollen and germination of pollen grain, or pollen receptive part, pollen accepting part, and the stigmatic surface is the site for germination of pollen grains. It is about the structure of a pistil or carpel. Carpel is one unit of gynoecium. Next, the style is a long stalk-like structure, or is a basal, swollen, ovule containing part. The structure of ovule. Another name of the ovule is integumented megasporangium. A megasporangium enclosed by some thecas or coats or some kind of protecting layers are found around the megasporangium. Such kind of megasporangiums are called integumented. Common name of that megasporangium is the ovule. Inside of that ovary, number of ovules are 1 to many. For example, it is structure of carpel. It has ovary as the basal swollen portion. Number of ovules inside of the ovary either 1 or more than 1. Different from plant to the plant. In some kind of plants, single ovule is found inside of the ovary. In another kind of plants, 2 ovules are per ovary. 3 ovule condition, 4 ovule condition, 5, 6, more than hundreds of ovules may also possible to present in ovaries of some kind of plants. The space found inside of this ovary is called, any kind of empty space is there, that is called ovarian cavity. Another name of that cavity is the locule. Another name of that cavity is a locule. Ovarian cavity or chamber or locule, all are similar words. So ovule producing pod inside of the ovary is also called as a placenta. Ovules always arise from a part of ovary wall, a small part of ovary wall, that is called placenta. This is the placenta. Okay. Next, another most important concept. After fertilization, listen very carefully. Ovary become as dash. Fertilized ovaries are, give answer. Or the fertilization, this ovule become as, students respond. Yes, good. Fruit. Once give the definition for fruit, fertilized ovary. What about ovules after fertilization? Good. Seeds. Likewise, give the technical definition for seed. Fertilized ovules are seeds. Fertilized ovaries are fruits. Generally, seeds present inside of the ovary because ovules found inside of the ovary. Seeds found inside of the fruit, reason ovules found inside of ovary. How many number of seeds are possible to present in fruits? You might have seen several fruits in nature. The number of seeds in a fruit is different from fruit to the fruit. For example, mango. How many number of seeds are found in mango? Single seeded fruit. Coconut fruit, tender coconut, single seed is there. Watermelon, number of seeds in watermelon. Watermelon. Many. Yes, many seeds because number of ovules in ovary also many. It is the transverse section of ovary. Inside of the ovary, single seed. One empty chamber is there, that is called locule. The part of ovary bear ovule is called as the placenta. Identify that image. Guess what is this image? It is a fruit only. Rice grains, fruit. Wheat, fruit. Maize grains also fruit. Inside of each and every fruit, one single seed is there. Just inner to the fruit, one seed is there. In case of the rice, the name of the fruit is called paddy. Paddy is the fruit. Rice is the seed. Okay. Botanically, paddy is the fruit. Rice is the seed. How many rice grains obtained from the fruit paddy? Only one. So, rice and wheat are example for single-seeded fruit. Single-seeded fruit. So, how can you differentiate the rice from paddy? Paddy is the fruit because that is the fertilized ovary, and rice is the seed because that is the fertilized ovule. Identify. What about these structures? Is it fruit or seed? Paddy, nothing but fruit. After removal of this husk, we can get seed. Paddy fruit is also single seeded. Name of the seed in paddy plant, rice. What is it? What is the name of this fruit? Yes, identify. Mango. How many seeds are in the fruit mango? Mango is also an example for single seeded. Single seeded. This is the only one seed. Because ovary for the single ovule only. Ovary for the single ovule. This entire structure is the ovary of carpel, and this is the ovule. After fertilization, ovary become as a fruit, ovule into seed. Give the example for ovary with many ovules or fruits with many seeds. At the fertilization, this is the ovary become as a fruit, ovules into seed. My question is, I name the fruits with many seeds. Name the plants in, yes, good, very good, watermelon. And papaya also. Papaya, fruit is a single, but more number of seeds are there. It explains number of ovules in ovary are more than one. One more example, guava, right? Papaya, guava, watermelon, pomegranate, good, strawberry. Right, strawberry single seeded. Custard apple, good. Watermelon, many seeds. It will be a single ovary for this many seeds. And orchids, in the fruit orchids also, more than 1000 seeds are present in a fruit orchid. Now the structure of ovule. Examination point of view, it is an important topic. We can draw the diagram and write the information also. Small subtopic is the structure of ovule. Another technical name of the ovule is megasporangium. Technical name of pollen chamber is the microsporangium. The technical name of pollen sac is the microsporangium, but the technical name of ovule is the megasporangium. Somebody are asking about what is the difference between embryo and I will explain in the next chapter. The name of the chapter, fertilization, I will explain about answer for your question. Okay. Structure of ovule. That is the ovary wall. Wall of the ovule. Inside of that ovule on diploid tissue is present. Diploid tissue. The name of this diploid tissue is nucellus. Nucellar tissue. Its fluid is the 2N. 2N means two sets of chromosomes are present in it. It is encircled by or enclosed by one coat that is called integument. The number of integuments are present in each ovule, either one or two, different from plant to the plant. Some of the ovules, two integuments are there. inner integument, it is outer integument. This is the outer integument. Nuclear tissue encircled by two integuments. Inner integument. Integument means coat. It is the outer integument. But it leaves a gap. Entire nuclear tissue is covered by the integuments completely, but leaves a gap at one particular area. That gap is called as the micropylar region or micropyle. Nothing but the opening of ovule. Micropyle is nothing but opening of ovule. Next, where the integuments and nucellus fuse, that area is called chalaja or khalaja. Chalaja, another pronunciation here, khalaja. Stalk of the ovule is called as funicle. Stalk of the ovule is funicle. Total how many parts are there in this ovule? The ovule is in young stage or immature condition. Nuclear tissue is there. The nucellus encircled by either one or two integuments. One is inner integument, next one is the outer integument. Opposite to the micropylar area, chala is there. Usually both micropylar region and chalaja opposite directions. Opening of ovule is called micropylar region. Opposite to the micropyle, the basal portion of the ovule is called chalaja. Stalk of ovule is funicle. And a point of contact between body of the ovule and stalk is called hilum. Hilum, H-I-L-U-M. What is hilum? It is the point of contact between body of ovule and a stalk is hilum. Once give the definition for the hilum. It is a point of contact between body of ovule and stalk of the ovule. That junction or point is the hilum. These kind of ovules are called as the orthotropous ovules. Ortho means striated. If micropylar area and chalaja is in only one vertical plane, then that kind of ovules are called orthotropous. Rare type of ovules are found in primitive plants. Orthotropous. But most of the flowering plants, the type of ovule is anatropous ovule. Identify the structural difference between orthotropous to most common type anatropous ovule. In this anatropous ovule also the central diploid tissue is the nuclear tissue encircled by integuments, either one or two integument. What is the name of the structure? Inner integument. It is the outer integument. Outer integument. Stalk of the ovule is the funiculus. The point of contact between body and funiculus is the hilum. Hilum, funiculus, body. Outer integument, inner integument, chalageal side, micropylar side. Identify the major variation here. Micropyle and chalazae present in only one vertical row and distantly arranged along with the funicle. Funicle, chalaja, micropyle all are present in one vertical plane. So this is the striated ovule without any curvature. But whereas here 180 degrees curvature bending is there here. 180 degrees curvature is there. Inverted ovule. For example, observe here in this finger. This is the top portion is the micropylar area. The basal portion is the chalaja. Is the chalaja micropylar in one straight plane, orthotropous. Due to the 180 degrees curvature, micropylar area come closer together the funicle. Micropyle and chalaja and funiculus very closely associated due to the 180 degrees curvature. Okay. That's why such kind of curved ovules are called anatropous ovule. It is the anatropous. The same diagram given in NCERT textbook in different notation. Okay, this kind of diagram is given our NCERT textbook. Tell me once again, what is the name of this area? Micropyle. This area is funicle. Whereas in orthotropous ovule, micropyle and funicle is in different directions and different places. Whereas in anatropous ovule, both are side by side. I will give one assertion statement. One assertion statement. In anatropous ovule, both funiculus and micropylar areas are side by side. What is the correct reason to explain this statement? What is the correct reason? 180 degrees curvature or bending is occur between body of the ovule and funiculus. That 180 degrees curvature is the reason for micropyle closely arranged at the side of funicle area. Okay, yes, good. The curvature leads to close association of micropyle and funicle. It is a characteristic feature of anatropous ovules. Micropyle. What about these two? Yes, good. Integuments. Two integuments are there. Whereas in some ovules only single integument is there. Next, what about the diploid tissue is found inside of the young ovule? What is the name of the bulkiest spots found just under to the integuments? Good. Nucellus. Nucellus tissue. Now, what about this point of contact between body and stalk? This one. No. Chalaja is just above. This area is the chalaja. I am asking about this one. Yes, good. Hilum. Hilum. What is the technical name of stalk of the ovule? Stalk of the ovule. Funiculus. Funiculus. So structure of ovule completed. For a leaf is also stalk is there. Stalk of the leaf is the petiole. For every flower is also having a stalk. May be present. The stalk of the flower is the pedicel. Stalk of the ovule is funicle or funiculus. Funiculus or funicle, both are similar words. Once again I will explain. Stalk of leaf, petiole. Stalk of the flower, pedicel. Stalk of the ovule, funiculus or funicle. Over with many ovules are present in papaya. Next question. Be ready to give answer. Basal part of the ovule is represented by basal part of ovule. Chalaja. Apical part or mouth of the ovule is micropyle. Stalk funicle. Which one represents the junction between the ovule and funicle? For the junction between ovule and funicle. Hilum. Next small topic here. Megasporogenesis. We learned about the microsporogenesis in last class. In this class, you have to learn about megasporogenesis. Formation of microspores is the microsporogenesis, but formation of megaspores from the megaspore mother cell inside of the ovule is known as megasporogenesis. Okay, what is the site of megasporogenesis? Megasporogenesis takes place in ovule. Ovule is the site for megasporogenesis. What is the site for microsporogenesis? You learned in last class. Microsporogenesis. This process occurs inside of the pollen chamber. Pollen chamber is the one of the portion of anther. Anther is the site for microsporogenesis. So, ovule, nothing but megasporangium, is the site for megasporogenesis. Definition for megasporogenesis. So, production of megaspores from megaspore mother cells. Ovules generally differentiate a single megaspore mother cell at the micropylar region of the nuclear tissue. At the micropylar region of nuclear tissue. It is the nuclear tissue encircled by integuments. Deep within the nuclear tissue, the total entire the white color portion of the nuclear tissue, only one cell of the nuclear tissue is modified into megaspore mother cell. It is the megaspore mother cell. Here was simplest question. How many number of cells are found in nuclear tissue? Unlimited. Unlimited number of cells. But how many megaspore mother cells are found? Only one per ovule. Out of many cells, just only one cell of the nuclear tissue is modified into megaspore mother cell. This cell is a heavy potential, are capable to undergo meiotic cell division. Meiotic cell division. What is another name of meiotic cell division? Reductional division. Other name of meiotic cell division is the RD, full form reductional division. As a result of the meiosis in megaspore mother cell, one linear megaspore tetrad is formed. The single cell undergo meiosis to form 4 daughter cells. 4 daughter cells are present, one above the other, linearly arranged. To the presence of 4 daughter cells, this structure is called megaspore tetrad. Megaspore tetrad. In this linear megaspore tetrad, the 3 megaspores present towards micropylar area degenerate. Only one cell of this tetrad present towards the chalazial side is the functional. Okay, among these 4, 3 degenerates. One degenerated, second one, third one. But only one megaspore is the functional out of 4 cells of this tetrad. These 3 are degenerated, this only one is the functional. The name of this cell is a functional megaspore. Means a fertile megaspore. So megaspore formation completed. Formation of megaspore from megaspore mother cell is known as megasporogenesis. This entire process or phenomenon is known as megasporogenesis. So what kind of cell division plays a significant role in the process megasporogenesis? Meiotic cell division. Meiotic cell division. This meiotic cell division is essential to form haploid daughter cells from diploid mother cell. The ploidy of megaspore is haploid. The ultimate aim of this meiotic cell division is the genetical recombinations as well as formation of haploid daughter cells. Haploid daughter cell from diploid mother cells. We learned about the microsporogenesis in last class. In case of inside of the anther or pollen chamber, microspore mother cells are there. Such microspore mother cells undergo meiosis in same way. Microspore mother cells also undergo meiosis to form microspore tetrads. Microspore tetrad. In megaspore tetrad, only 3 are degenerates, only 1 is the functional. Whereas in microspore tetrad, all are functional. All daughter cells are functional. It is one of the major variation or difference between microsporogenesis to megasporogenesis. In microsporogenesis, microspore mother cells are there. Microspore mother cells. Another name of the microspore mother cell is the polar mother cell. After a single meiotic division or reductional division in this single microspore mother cell, it gives rise to pollen tetrad or microspore tetrad. Microspore tetrad. This is the structural representation of microspore tetrad. 3 cells are very cleavable. One more cell is there in backside. Among these four are fertile. There is no degeneration. All are fertile. Everyone is the functional. So every microspore mother cell gives rise to 4 functional microspores, whereas in megasporogenesis, each megaspore mother cell can yield single functional megaspore. Based on these concepts, we can make some number of questions here. Be ready to answer for these questions. To yield 16 microspores, functional microspores, how many number of meiotidians are required? Listen once again. To yield 16 microspores, nothing but pollen grains. After maturity, these are the microspores are called as the pollen grains. To yield 16 pollen grains, required number of meiotic cell divisions by 4. 4 are required. At each meiotic cell division, 4 daughter cells are formed. Every daughter cell is a functional. There is no degeneration of any kind of microspores. In case of megasporogenesis, single meiotic cell division can yield only one functional megaspore. To yield 16 functional megaspores, F functional, M megaspore, 16 meiotidians are required. Finally, we can conclude number of meiotic divisions are equal to number of functional megaspores. Whereas in microsporogenesis takes place inside of the anther, number of microspores by 4 equal to meiotic cell division. Each meiotic cell division can yield 4 microspores, 4 are functionally. Whereas in megasporogenesis, each meiotic cell division can yield only one functional. Earlierly 4 spores are formed. In the 3 degenerates, only one is the functional. It is one of the major variation between microsporogenesis to megasporogenesis. It is a completely development of structures occurs inside of the male organs. It is in female organs. Male organ is the anther, female organ is ovule. Observe these diagrams here. It is a large cell containing dense cytoplasm. It is means megaspore mother cell. Due to the first phase of the meiosis, only 2 daughter cells are formed. At the completion of second phase of the meiotic cell division, 4 daughter cells are formed. The same kind of images given in your NCERT textbook. Out of these 4, 3 degenerates, last one is the functional. MMC means megaspore mother cell. What kind of cell division occurs in micro and megaspore mother cells? Meiosis. I will explain about the structure of female gametophyte and development of embryo sac in next class. Okay, understands. Right, thank you. Bye now.
Hello everyone. Hello students. How are you? So welcome back to my lecture. So now we'll continue our topic of animal tissues. So let me start the class without any delay. Right. So yesterday we have talked about the animal tissues beta. I will just give you a recap, quick recap that what we have studied yesterday. Animal tissues. So I have told you that tissues originated first in which phylum? Coelenterata phylum, right? And after tissues, the organs and then organ system. This is the level of organization present in the animal body. So animal tissues are present everywhere in our body. It is very, very important to know which tissue is present in which part of our body. So we have 4 types of tissues beta. I have told you epithelial tissue. Then today I am going to brief you about the connective tissue, then there is muscular tissue, and then there is nervous tissue. So yesterday we talked about epithelial tissue. I have told you that the origin can be ectodermal, mesodermal, endoderm. All the three germ layers can originate the epithelial tissue. I have told you the function that it covers or lines the various organs of the body internally as well as externally, and it protects and it gives protection. So covering and protection is the function of epithelial tissue. And then I have told you two types of epithelial tissue. Two types. I have told you two types. One is simple and one is compound, beta. I have told you two types. One is simple and compound on the basis of the layer of cells. If single layer of cells, it is simple. If many layers, more than one layer, it is compound. Yes or no? Alright. So now I have told you simple can be of different types. It can be simple squamous epithelium. It can be simple cuboidal epithelium. It can be simple columnar epithelium. These are the main types. Then I have told you in cuboidal and columnar, modifications can be there. Above the cell, on the apical surface of the cell, I have told you microvilli can be present, right? Then we will say it is brush bordered epithelium. Cilia can be present. Then we will say it is ciliated epithelium. So the cuboidal without modification will be smooth. With modification of microvilli, it will be brush bordered. With modification of cilia, it will be ciliated. Similarly, columnar epithelium can also be smooth without modification. It can have microvilli, brush bordered, and it can have cilia, so ciliated epithelium. So these are the further types of cuboidal and columnar. If cuboidal cell is there, it has no modification, it is simple smooth cuboidal. But if it has microvilli, it is simple brush bordered cuboidal. If it has cilia, it will be simple ciliated cuboidal epithelium, right? Now we also have one more type, that is pseudo-stratified, beta. Pseudo-stratified. In this pseudo-stratified also, the cells are columnar only. It also has columnar cells. But some of the columnar cells are big and some of the columnar cells are small. We will see the details of this once you come to my class, right? Once you come to my class, once you come to this campus, we will see the details of this. Then there is glandular epithelium, beta. Glandular epithelium. So we will see the details of all the glands. On the glands, there is a separate chapter, that is chemical coordination and integration, right? So in this also, the cells can be cuboidal or columnar. The cells can be cuboidal or columnar. So basic is squamous, cuboidal and columnar, three shape of cells. On the basis of that, simple epithelium types are there. Similarly, compound epithelium also types are there, beta. In the compound epithelium, there can be many layers, stratified, and there can be less than stratified, less number of layers, then it will be called as transitional. So if more than one layer of cells are there, that will be compound. Stratified, many layers of cells are there. But in transitional, less number of layers are there as compared to the stratified. We will look into the details of stratified also, transitional also, once you'll come to my class, right? But at least you have got a brief introduction about epithelial tissue. What you are going to understand in the epithelial tissue, that you understood, right? What you are going to study in the epithelial tissue, that you have understood, right? So now this is the briefing of the epithelial tissue. Now there is one more important topic in the epithelial tissue, that these cells have junctions, and these junctions are known as cell junctions. main three types of cell junctions are there. There are tight junctions, there are gap junctions, right? And there are adhering junctions. Adhering junctions. These three types of cell junctions, these are the main types. They are mostly found in which type of tissue? Epithelial tissue. If somebody will ask you question, cell junctions are most likely to be found in which tissue? Then you will say epithelial tissue. But that doesn't mean that the cell junctions are not present in any other tissue, beta. Cell junctions are present in other tissues also, but they are most likely present in which tissue? Epithelial tissue. Epithelial cells will have junctions, cell junctions, right? Now, I am going to tell you about the next tissue, and that is beta connective tissue. So, in today's class, we will talk about the connective tissue. In today's class, we will talk about the connective tissue. So now, how many of you remember what is the origin of connective tissue? Tell me quickly in the chat section. Tell me quickly what is the origin of connective tissue, beta? Yes, come on everyone. Tell me what is the function, what is the origin of connective tissue? Yes, very good, Ratna, Shushant. Everyone is giving the correct answer, Muskan. Right, all right, everyone is giving the correct answer. So, mesoderm. It is mesodermal in origin. Right, mesoderm is the origin. You know the function? Function is to connect. To connect various organs, to connect various tissues in the body, right? Now, I will tell you what exactly is forming this connective tissue. What are the components of connective tissue, right? So, let us see the components of connective tissue. Connective tissue components. So, beta, there are three components. Right? There are three components. One is the matrix. Another is the cells, and the other is the fibers. There are three important things in the connective tissue. One is known as matrix. Matrix can also be called as ground substance. So let me explain you first what is the meaning of matrix or ground substance. See, whenever we talk about a class, like this is a live class. So what are the components of the live class? I am the component, you are the component, right? Without the teacher, class cannot be there. Without the students, class cannot be there. Without the studio, class cannot be there. So this is the ground substance. This is the actual requirement. The studio is the actual requirement, because through the studio you are able to hear me, and because of this studio I am able to interact with you all. Yes or no, everyone? So this is the ground substance. Just like that, connective tissue has also so many cells and fibers, but where these cells and fibers are present? So these cells and fibers are present in the ground substance, the matrix. And this matrix or ground substance is made up of what? Just like the studio is made up of what? Just like the studio has a room, has a setup, this board, this camera, everything is there, right? Just like that, this matrix is also made up of few substances. Those substances are ground substances made up of glycoproteins and mucopolysaccharides. These are those polysaccharides, beta, which are mucilaginous, mucopolysaccharides. I will tell you the name of one mucopolysaccharide, that is hyaluronic acid. hyaluronic acid is the most abundant mucopolysaccharide in the matrix of connective tissue. See, you must have heard of proteins, carbohydrates, alright. So these proteins and carbohydrates only are forming the matrix beta, right? So this mucopolysaccharide, I'm giving you one example, one name, and that name is hyaluronic acid. Hyaluronic acid. Hyaluronic acid. So hyaluronic acid is the most abundant mucopolysaccharide in the matrix of connective tissue. This is the most abundant mucopolysaccharide. That doesn't mean that not other mucopolysaccharides are present. Others are also present. But which is the most abundant mucopolysaccharide? Hyaluronic acid, right? Then coming to the cells. Many cells are there. Many cells are there, right? For example, how many cells are there? Many cells are there. For example, I will tell you some of the important cells. And these cells are, the most abundant cell is fibroblast beta. This fibroblast is going to secrete the matrix also, and this fibroblast is going to secrete fibers also. So it is very, very important cell. It is required because it is making the components of the connective tissue, right? So fibroblast is the most abundant cell of connective tissue, most abundant. And what is the function of this? It secrete matrix and fibers. It secrete matrix and fibers. Why its name is fibroblast? Because it secretes fibers beta. Mainly it secretes fibers. So these fibers are of two types. I will tell you the two types of fibers. But first let me tell you more cells like adipocytes. There are adipocytes beta. Do you know what is adipose or adipocytes? Adipose means fat. Fat storing cells are adipocytes beta, right? So adipocytes will store what? They will store fat. They store fat. They store fat. They store fat. More cells are there like mast cells are there. Mast cells are there. Like macrophages are there. Macrophages are there. Like plasma cells are there. Plasma cells are there. Right? Then you will find WBCs also. WBCs also. Right? So now you will find so many cells. What is a mast cell? Mast cell. What is a mast cell? Mast cell is a cell which is having a granular appearance, dotted appearance. I will show you all these things by the help of a diagram. But first listen to me, and then when you will look upon the diagram, you will understand each and everything. Alright? So now, mast cells are having dotted appearance, and they secrete some chemicals which are, they are very must. You know must. Mast cells are very, very must. They are secreting some chemicals, and these chemicals are, they secrete what chemicals? Histamine, serotonin, heparin. Once you will come here, once you will attend the lectures, then you will understand everything in very, very detail. Right? Because in these classes we have limited time, so we just want to, give you a glimpse of the chapter, glimpse of the topic. But we cannot cover the topic, each and every topic in very, very detail or depth. But still, I will tell you, histamine will dilate your blood vessels. It is a vasodilator. Serotonin will constrict your blood vessels. It is a vasoconstrictor. And heparin is a Very, very important chemical, because if heparin will not be there, yes, exactly correct, Ratna is exactly correct. Heparin is anticoagulant, beta. Your blood in your body is in liquid form. If anticoagulant will not be there, it will coagulate, it will clot, it will coagulate. If it will coagulate, then it will not flow, and the flow of oxygen and nutrients, everything will stop. Right? So, anticoagulant is very important. So, heparin is anticoagulant. So, these are mast cells. Then coming to macrophages, yes, they are also very important. They will engulf, they will eat. These are the eater cells, beta. These are the eater cells. So, yes, it is also, heparin is also used in dialysis, yes. So, now, macrophages are the cells which perform phagocytosis. What is the meaning of phagocytosis? Eating, engulfing. If there is a waste in the cell, if there is a pathogen in the cell, so that pathogen should not be there, otherwise it will cause harm, right? So, macrophages will perform phagocytosis. Phagocytosis. Plasma cells are also very important. Plasma cells are those cells which will secrete antibodies. Antibodies for us. Do you know what is antibody? Antibody is a very, very important protein which is formed in our body by our immune system, by the plasma cells to protect us from the diseases, to protect us from the pathogens, right? So, plasma cells will produce antibodies. They will produce what? They will produce antibodies. These antibodies, they will kill the pathogen. They kill the pathogen. Pathogen is the disease causing organism. It causes the disease. It is very harmful. So that is why the antibody will kill it. Antibodies are bullets, beta, bullets. Antibodies will kill the pathogen. WBCs like neutrophil, eosinophil, basophil, these will be present. Like neutrophil, I will teach you blood in detail in the next class. So then I will teach you WBCs also. So neutrophils, eosinophils, right? Etc. etc. Total 5 types of WBCs are there. I will teach you in the next class. So all these cells are present in the matrix of connective tissue. All these cells are present in the matrix of connective tissue. Now I will talk about the fibers. I will talk about the fibers, beta. Fibers. These fibers are of 2 types mainly. Mainly of 2 types. One is the collagen fibers and another is the elastic fibers, beta. Elastic fibers, right? Collagen and elastic fibers. Collagen fibers are the fibers which are white in color. So that is why they are also known as white fibers. Collagen or white fibers. Collagen or white fibers. And the elastic fibers, they are yellow in color. So that is why they are also known as elastic or yellow fibers. Elastic or yellow fibers. Now, the differences are collagen fibers are made up of which protein? They are made up of collagen protein, beta. They are made up of collagen protein. Whereas elastic fiber is made up of which protein? Elastin protein. Elastin protein. Remember, these are the small, minute differences in the terms where you have to be very careful. Elastic is the fiber, elastin is the protein. Protein, elastin, right? So are you understanding? Now, collagen fibers, you will see them in the bundles. They are in the bundles. They are present in the bundles. They are not branched. They are unbranched. They are unbranched, beta. So when anything is present in the bundles, when anything is present in the group, when you have a strong group of friends, then you can fight with anybody. You will have so much of strength. You must have heard of that story, right? Stick. One stick can be easily broken. But when so many sticks are there together, can you break those sticks? No. Yes. So that is how collagen fibers, they provide strength. What they provide? They provide beta strength. Right? They provide strength to the connective tissue. Whereas elastic fibers, you will not find them in bundles. They are present individually. Right? They are present what? They are present individually, singly. Individually they are present. And they are not unbranched. They are branched. They have branching. They are branched. I will show you. They are branched. Then they provide, if they are branched, they cannot provide strength. If they are individually present, they cannot provide strength, but they can provide elasticity, as their name suggests, elasticity, right? So elastic fibers, they provide what? They provide elasticity. They provide beta elasticity. So now I will show you these cells and fibers in the matrix of connective tissue. I will show you these cells, fibers and matrix in the connective tissue. So in the connective tissue, I have told you three components beta. One is the matrix, which is the ground substance. Another is the types of cells. Many types of cells are present. These are few examples. Then fibers. What are the main fibers? The main fibers are collagen and elastic fibers. One more fiber is also there, that is known as reticular fiber beta. One more fiber is also there, that is reticular fiber, but it is not the main fiber. The main fibers are collagen fibers and elastic fibers, but you will see reticular fibers also. They are also just like collagen fiber, but they are made up of reticulin protein. Reticulin protein. They are white in color just like collagen fibers. They are white in color just like collagen fibers, but they are not unbranched. They are also branched. They are not present in bundles. They are present individually, right? So they are branched beta. White branched. White and branched fibers made up of reticulin protein. But main fibers are collagen and elastic fibers. So tell me till here, have you understood the components of connective tissue? Yes, everyone. Yes, everyone. Please tell me in the comment section, have you understood the three components of the connective tissue? The three components of the connective tissue are matrix, cells and fibers. Where these cells and fibers are present? They are present in the matrix. All right. Thank you. All right, everyone. All right. So now let me show you the diagram. As you can see, this is the NCERT. This is our holy book. You have to read NCERT. You have to always keep NCERT close to your heart, beta. Close to your heart. Right? You should always be carrying NCERT. You should never come into the class without the NCERT. Right? That is what the habit you have to make. This is the best habit of studying, biology. NCERT should be there always with you. So now this is the diagram of NCERT. This is the diagram of areolar tissue. Areolar tissue is one type of connective tissue. I will tell you the types of connective tissue, but let us see the beautiful components of the connective tissue. Let us see the beautiful components of the connective tissue. Anyone? Yes, everyone. Can you see the fibroblast? Can you see the fibroblast? This is the fibroblast, beta. Can you see the fibroblast here? This is the cell. And from this fibroblast only, beta, this is not complex. This is very simple. This diagram is not complex. Just listen to my words. It will be very easy for you. Right? So this is the fibroblast. These fibers are coming from the fibroblast. Can you see these fibers? These fibers are which fibers? Which fibers are present in bundle? Yes, everyone. Which fibers are present in bundle? Collagen fiber. So that is why these are labeled as collagen fiber. Can you see any fiber here which is yellowish? Yes, everyone. This is the yellowish fiber. This is the yellowish fiber. Can you see this fiber? This is the yellowish fiber. This is the elastic fiber, beta. This fiber is the elastic fiber. This is the elastic fiber. Elastic fiber. This fiber is elastic fiber. So you can see here the difference. The collagen fiber is present in bundle. This is the collagen fiber, bundle of collagen fiber. This is not branched. But this yellow colored fiber, or you can see orangish, it is actually yellow fiber. It is beta branched. It is present individually. It is present individually. It is not present in bundle. Next thing, can you see a big cell which is known as macrophage? This is macrophage, beta. Macrophage. Then can you see a cell which has very mast appearance? Mast cell. Mast cell. Dot. These are the chemicals which it secretes. It has a dotted appearance. These are the chemicals which it secretes. Right? Then you can also see the two cells together here. Can you see these two cells together? These two cells. These are beta. These are the adipocytes. This cell and this cell. These are adipocytes. These cells, they store fat. These are adipocytes. Adipocytes. Then, can you see this cell here? Can you see one cell is present here? This cell is beta plasma cell. Plasma cell. Which secretes what? Which secretes antibodies. Now, there are two more cells which are the WBCs. They cannot be the RBC beta because RBC in humans are enucleated. They don't have nucleus. The cells which you are seeing here, they have nucleus in them. WBCs are nucleated. What is the difference in the nucleus? I will teach you tomorrow. There are differences in the nucleus of different WBCs. In the shape of nucleus of different WBCs, there are differences. Right? So, you can see all the cells. You can see a macrophage. You can see a fibroblast. This is a fibroblast. This is a fibroblast. This is a macrophage. These two are adipocytes, beta. This is mast cell. This is plasma cell. And these two are the WBCs. This is a neutrophil. This is a eosinophil. So the cells which I have told you, I have shown you those cells in the diagram. Now you can also see the fibers. I have told you the fibers in bundle. Collagen fibers, branched fibers, elastic fibers, and one more fiber here. Can you tell me one more fiber? With which color you can see one more fiber? With which color? Beta Ratna, I said collagen fiber is white, but in picture it is blue because if they will make with a white color, how you will be able to see beta? How you will be able to see the white color? So that is why to distinguish the fiber, they have made it with the different color. Here whatever color is there, that is not the actual color. Right? So, you have to understand that. So here, yes, the pink fibers. Yes, everyone. Yes, so many of you are saying it correct. Pink. Yes. Pink fibers are beta reticular fibers. Now I can say they are also white. Reticular fibers are also white. Now I have told you collagen fibers are also white. Reticular fibers are also white. So that is why they have to give some color so that you can understand and distinguish between the fibers, right? So reticular fibers, the other fiber which you are seeing here with the pink color is beta reticular fiber. So where these all things are present, the fibers, the cells, where all these things are present, beta? These are present in the matrix. So this is the matrix. This is the matrix. This is the matrix, ground substance. This is the matrix where all these things are present. So now you understood the connective tissue. You understood the components of the connective tissue. The components of the connective tissue are matrix, cells and fibers. I have told you many types of cells. I have told you mainly 2 types of fibers and 1 more fiber additionally. 3 types of fibers total. All these things are present in the matrix. Okay, Ratna beta, I'm glad you understood. So now let me tell you the types of connective tissue, beta. You know that this is the tissue which is the most abundant in our body, right? So now let us see the types of connective tissue. So I will explain you the types of connective tissue in brief. Types of connective tissue. Types of connective tissue. If somebody will ask you which connective tissue is most abundant, then see, if somebody will ask you which tissue is most abundant, then you will say connective tissue. But in the connective tissue also, which tissue is most abundant? So there are 3 main types of connective tissue. Loose connective tissue, dense connective tissue, and beta specialized connective tissue. Specialized connective tissue. Right? Loose connective tissue is the most abundant. It is the most abundant tissue. It is the most abundant tissue. Why its name is loose connective tissue? Because arrangement is loose. Let us suppose there is a classroom and in that classroom less students are there. So arrangement will be loose, right? They can sit, one person can sit at one bench and so many benches are there. But when the classroom strength is very high, all the benches will be completely filled. Yes or no? Very dense arrangement. So many students are there in a small classroom. So very dense arrangement. Just like that, when cells and fibers are loosely arranged in the matrix, then it is a loose connective tissue. When cells and fibers are densely arranged, then it is a dense connective tissue. So here we can write in loose connective tissue, cells and fibers are loosely arranged. Loosely arranged. Where? In the matrix. Cells and fibers are present in the matrix only. So the arrangement is loosely arranged. Whereas in the dense connective tissue, cells and fibers are densely packed, are densely arranged. Now this arrangement, densely arranged, this arrangement can be of 2 types, beta. Arrangement can be regular, arrangement can be, yes, space will be more in the loose connective tissue. Yes, absolutely correct. I don't know your name, but Movie Plus is saying something, space will be more. Yes, definitely space will be more in the loose connective tissue. In dense connective tissue, space will not be there. Very less space will be there in the matrix because cells and fibers are more. Now, their arrangement can be of 2 types. It can be dense regular. It can be dense irregular. It can be dense irregular. So, regular and irregular arrangement can be there. Regular arrangement means they are having a regular, for example, let me just draw a rough diagram so that you can see, let us suppose this is the matrix and this is also the matrix. If cells are present anywhere, one cell is present here, 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 like this. This is an irregular arrangement. But if cells are present like this, in a row, In a row cells are present, beta. So then, so let me write this as irregular and this as regular, because I have made it like that. So I am making irregular here, and here I am making regular. So you can see a regular arrangement, beta, of cells and then fibers. Can you see? Fibers, they are having regular arrangement or irregular. Here anywhere fibers will be present like this. Here there is no regular arrangement. Are you understanding the difference between regular and irregular? Sometimes you are regular in the class. You are attending class daily. You are writing notes. You are doing everything. Regular, regularly, daily. Right? Just like that, regular arrangement is there. One cell, one row of cells, then fibers, then cells, then fibers. Like that. Regular arrangement. So this is the types of dense connective tissue. Then there is specialized connective tissue. Beta, they have special function. They have special function. Either they are making your endoskeleton, or they have a speciality that they are doing a specific function of transportation in the body. So specialized connective tissue will be of two types. One is skeletal connective tissue and another is fluid connective tissue. Fluid connective tissue. Skeletal connective tissue. Our endoskeleton is made up of bones, beta. Also made up of cartilages. So skeletal connective tissue is of two types, cartilage and bone. You know about all these things, right? You know, do you know that this is a cartilage, this is a cartilage? Yes or no? Then you know about bones. We have so many bones, 206 bones are there. Fluid connective tissue. There is one major fluid, that is blood, beta. The main fluid in our body is blood. But from the blood, one more fluid is formed, that is lymph. I will tell you how lymph is formed from the blood. So there are two total fluids in our body. One is blood and one is lymph. So now these are the types. If you look at loose connective tissue, there are two types in loose connective tissue. One is areolar tissue, one is adipose tissue. This areolar tissue is more abundant, most abundant among these two. Then dense connective tissue, regular and irregular. Regular is also of two types. There can be tendon and ligament. Have you heard of tendon and ligament, beta? Have you heard of tendon and ligament? So this is the chart which is, which is the mind map for the connective tissue. You have to remember this mind map if you want to understand the types of connective tissue. Loose connective tissue, loose arrangement. Dense connective tissue, dense arrangement. Specialized connective tissue, special function. Loose connective tissue, areolar tissue, adipose tissue. Dense connective tissue, regular, irregular. Dense, regular connective tissue, tendon, ligament. Specialized connective tissue, skeletal, fluid. Skeletal connective tissue, cartilage, bone. Fluid connective tissue, blood and lymph. From blood only lymph is formed. From blood only lymph is formed. Beta, blood, lymph, plasma, everything, all the differences I will teach you tomorrow. So tomorrow's class is all about blood, khun, blood. It is all about blood, tomorrow's class. Don't miss tomorrow's class. I'm going to teach everything about the blood. So I am concluding this class here only because time is over, right? You must be hungry also. You need to go and have food now, right? So now let us meet tomorrow exactly at same time. Stay tuned. And sorry, not tomorrow. I forgot. Tomorrow means Monday, right? Not tomorrow. Tomorrow you can enjoy. Tomorrow is Sunday, beta. I can also enjoy. You can also enjoy, right? So not tomorrow, day after tomorrow. All right, everyone. So see you, my kids, day after tomorrow on Monday. Stay regular, stay tuned, subscribe the channel. Don't forget to subscribe. If you have understood these lectures, so this is the motivation for us. If you like the you like the session, if you will subscribe to the channel, this is the motivation for us to teach you. So that is why like this session if you have understood my class. Those who have not liked the session, like it. Okay, so chalo, then see you